Okay, so this is the last part of 4.3, and then we'll be finished with 4.3, and we'll move to 4.2. 4.2, oh my word, some of y'all are gonna be like, what? This is so cool. Some of y'all are gonna be a little lost, and it'll take you a while, but it's okay, all right? It's okay. So we're gonna solve word problems using right triangle trigonometry. So the biggest problem that we run into are when they use these words, angles, or angle of elevation and angle of depression. So angles of elevation and angles of depression. Y'all, the air was broken, so that's why it's so hot in here, okay? They fixed it, and you know, it's working now, but it'll take it a little while to catch back up. All right, so anytime you see angles of elevation and angle of depression, you need to go, uh-oh, okay. This one right here, he's the one that messes more kids up. He will be depressing for some of you because he will make you miss the problem, all right? So if you see angle of depression, go, oh, I gotta make sure, okay? So they are formed with a horizontal. All right, they're formed with a horizontal. So let me give you a visual of that, okay? And I'm going to tell, what I'm trying to do is I'm trying to show you what the most common mistake is and keep you from making that mistake, okay? So got me a little building right here. On top of my building, got this little man. He's not jumping, okay, so it's okay. He's looking, all right, at this mean dog down here.
You're a 5-star artist.
Okay? Oh, his eyes a little far back, but whatever. Okay, so he's looking at this dog. So here's what I want you to do. Now, I haven't drawn anything with the picture, okay? So if I said there's a man on a building, he's looking at a dog on the street. What is the angle of elevation from the dog to the man? What is the angle of elevation from the dog to the man? Angle of, I want you to draw it, of elevation from the dog to the man. Now this is the easy one, do you agree? Okay, because even though I didn't draw anything, 99% of you will get this one right, all right? Because you went from the dog to the man, and then you knew that this was the ground. Do you agree with me? This is my angle of elevation. Did y'all get that right?
Yes.
Very good. Okay, so here's the one that's scary that'll mess people up. Tell me what the angle of depression from the man to the dog is. I want you to mark it on your picture. The angle of depression from the man to the dog. All right, everybody got it? Okay. Did you mark this angle right here? Is that formed with a horizontal?
I made a little line.
That's exactly right, okay? So here's what happens all the time. An angle of depression, most of the time it's with the ground, and your eye sees the ground even if I don't draw it. You're like, oh, okay. But an angle of depression, your eye's gonna go right here. Y'all, that is not an angle of depression. That's formed with a vertical, not a horizontal. So you physically have to draw this angle here. This is my angle of depression. Okay? Your eye does not naturally see this line, so you have to go, this is the angle of depression, those are the ones. I have to draw the horizontal. I'm not gonna see it, okay? If you call it this angle right here, you'll miss the whole problem, all right? Now, what do you know about all horizontal lines?
They're 180.
They're all what?
Parallel.
Parallel. These are all parallel to each other, okay? All horizontal lines are parallel. So if those are my parallel lines, and this is my transversal, okay? These two angles right here are called alternate interior angles. Do you see? This is why they're called that, guys. They're on alternate sides of the transversal, and they're on the inside of my parallel lines, okay? What do you know about alternate interior angles of parallel lines? They're the same. These things, y'all, they're equal to each other. They're the same thing, okay? They're equal to each other. Huh? They're congruent, yes. All right, so everybody got it? All right, so here we go. Let's start working our problems. Example 7. Example 7, here's what you said. Now look, on your problems, you're going to have to draw the picture, okay? I like to draw pictures, so mine, I like to embellish a little bit, but you can just be kind of, unless you like to draw. So here's your problem. This is what it reads. As we read it, we're gonna draw it, okay? So a surveyor is standing 50 feet from the base of a large tree. All right, so meet us a big tree. Okay, and then we got a little surveyor over here. Got his little surveyor hat on. Okay, and how far is he?
50 feet.
50 feet. Are you with me? Okay, now, have you ever seen surveyors before?
No.
You see them out on the road sometimes? Yes? Okay, a lot of times when you see them on the highway, they are, they're measuring and looking through, it's called a sextant, okay? It's a tripod, it has a little camera thing, and they're really measuring to see where does the double yellow line start? Where's the no passing? Where can you not see when the cars are coming? You have to have so many feet, and all that kind of stuff. If you see them on people's property, they're usually either marking off a property line, okay, with a surveying tool, or they are finding water lines or gas lines or something like that, so that if you're digging, you're not gonna hit them, all right? So here's the next thing it says. A surveyor standing 50 feet from the base of a large tree, as shown in the, we drew on the picture. The surveyor measures the angle of elevation to the top of the tree as 71.5 degrees. You draw it. The surveyor measures, he used a sextant to measure that, okay? It's just a little tripod thing, and you can point it at something, it'll tell you angles of elevation, angles of depression, tell you distances, all kinds of stuff. Angles of elevation to the top of the tree is 71.5. Did everybody get it? So, he measured the angle of elevation to the top of the tree. This angle is 71.5 degrees. Are you with me? It wants to know how tall is the tree. There's my right triangle. Okay? There's my right triangle. So, once you get, now y'all, listen to me, right now, the only kind of triangle that you can use tree functions on are right triangles. This whole section is called right triangle trigonometry, okay? So, once you get it, I'm going to label the sides with respect to this angle, okay? I'm only gonna label the sides that I need. Obviously, I'm probably gonna need this one because I know the measure of it. I am gonna need this one because it's what I want to know. So with respect to this angle, I'm gonna label the sides, either opposite, hypotenuse, or adjacent. So what would this side be?
Opposite.
Opposite. And this side would be?
Adjacent.
Adjacent. This side is your hypotenuse. I'm not writing it on there, okay? I'm just writing the ones that I need, because then I just look at it and I go, oh, what function deals with opposite and adjacent? What is it? Tangent?
Yes.
Okay, So tangent of theta is equal to opposite over adjacent. Okay, now look, if this were my paper and these were the problems, I'd probably go up somewhere on my paper and I would go sine, cosine, tan. Oh heck, heel of ants. Okay, opposite over adjacent, oh that's tan. Okay, obviously we're not gonna use these ones over here because they're not on my calculator. Okay, so I'm only gonna use the ones that are on the calculator. So let's plug all our stuff in. So I'll have the tangent of, what is theta?
71.5.
71.5 degrees is equal to, what's opposite? X over, what's adjacent? 50. Now, I'm solving for X. Tell me what to do. Yeah, multiply both sides. They divided by 50, so you do the opposite. I multiply both sides by 50. Okay? And so, X is equal to, y'all, you're gonna need a calculator. So, should you have brought your gel and Ziploc bag if you don't have your own calculator? Yes? Alright. So, here's the first thing you have to do. Does anybody need a calculator? Yep, okay. I got some on my desk and just open the baggie up and I'll come drop one in for you.
I don't have a bag.
Mm-hmm.
This is,
Yeah,
I don't have a calculator.
you don't have that? Okay, well, you just have to wait.
We have to put in
Yes, that's the very first thing that you wanna do. The first thing that you wanna do is you wanna go to mode on your calculator, and you wanna make sure that your calculator is in degrees. I would say generally yours is probably in radians, and it probably looks like this, okay? So if it is in radians, you're gonna go down, go to the right. Y'all, that's not in degrees. It's asking you, do you want to turn it into degrees? So you press enter, and then it pops it over there, and then you go second and quit. Okay? We're in degrees, so you have to be in degrees. All right, so we're gonna do this on our calculator. I'm just gonna say 50 times the tangent, you press the tangent button, of 71.5.
Where's the tangent button?
The tangent button's
Oh,
right
it's
here,
right there.
right? There are 2 rows above the top numbers. It goes sine, cosine, tangent. All right? I would get in the habit of closing the parentheses because, y'all, if you put that times 50 back here and you didn't close the parentheses, you would be wrong, okay? Because you would be taking the tangent of 71.5 times 50. So, but if you close the parentheses and then said times 50, you would only be taking the tangent of 71.5. So, that's a good habit to get into. So, here's my answer. X is equal to 149.43 feet. The reason it's in feet is because this is in feet. All right? Is this a reasonable answer?
Yes.
Yes. Okay? Y'all, if it's a reading problem, always make sure you think it's a reasonable answer. Okay? So, it said it was a large tree, so if I'd have gotten 14.9, I would have said, what? Like, no, that's not right. Let me show you most of the time. Now, y'all listen, if it wasn't a reading problem, you might not notice. Okay? But most of the time on a reading problem, if you forget to change the mode, I'll show you what'll happen. I'll go back and do the same problem. Okay? Look at my answer. Is that reasonable? What does that tree look like? Probably one around here, right? Negative 47.20. No, that's crazy. Then you go, oh man, I must have forgot to put that thing in degrees. All right, anybody got a question? Okay, let's move on. All right, here's our next problem. We got 2 more and then we're done. So the next problem reads like this. You are 200 yards from a river. All right, so we got us a little river here, okay? because it's got some water in it.
What example is example 8?
I'm sorry, what?
Is this example 8?
Oh, it is, example 8, yeah. Sorry. Got a little duck in it. Becky, my daughter Becky, I don't know how she acquired a duck, but she got a baby duck. I do. She went up to Tractor Supply and bought the dang thing. Brought him home. His name was Ferdinand. She rocked him to sleep every night. That duck he thought he was a dog. He followed our dog around everywhere. And he stood at the back window and would peck on the window and quack. Because he was like, you let the dog in, let me in. No, ducks are very messy. They poop a lot. All right, so you are 200 yards from the river. So I'm gonna be over here somewhere. My hair's crazy today. All right, 200 yards. Okay, you are 200 yards from a river. Rather than walking directly to the river, that would be the 200 yards, okay? You walk 400 yards along a straight path to the river's edge. So you're gonna walk 400 yards on a straight path that goes to the river's edge. Find the acute angle theta. I want you to put theta where it belongs. Find the acute angle theta between this path and the river's edge. Find the acute angle theta between this path and the river's edge. Does everybody know where theta is?
Yep.
Is it here?
No.
No, it's right here. Okay, so they want me to find this angle. So with respect to this angle, I'm gonna label my sides. With respect to this angle, this side would be called what? Opposite. And this side would be called?
Adjacent.
Yeah, he's opposite that right angle, okay, so he is the hypotenuse. All right, so what function? Now see, if you did that, you look back over here and you go, what function deals with opposite and hypotenuse? See, opposite and hypotenuse. Oh, I'm going to sine function. So I'm gonna say the sine of theta is equal to 200 over 400. Do you agree? Okay, now, here's something really important. Star it, write it in your favorite color. You wanna make sure you know it. You only use sine to the minus 1, which is also called inverse sine. When I say it, this is what I say. I don't say sine to the minus 1, okay? I say inverse sine. It's also called arc sine. That means inverse sine. All of these things mean the same thing, okay? All of these things mean the same thing. And you only use the inverse function when you're, and I misspelled this on all the other classes and they didn't even tell me. When I put your, like while you are. When you are looking for an angle. Very, very important.
Can't that be used for all the others though?
Yes,
Like the same
anytime you're looking for an angle, that's when you'll use the inverse function. You never, ever use the inverse function unless you're looking for an angle. Am I looking for an angle?
Yes.
Yes. It says the sine of what angle is equal to 200 over 400, okay? So I'm gonna rewrite it like this. Inverse sine of 200 over 400 is going to be my theta. All right, I'm gonna put it in my calculator just like that, okay? Now y'all, once you change your calculator to degrees, it stays in degrees. Unless someone changes it, or it may go back to radians when you reset that RAM thing like y'all do, second memory, all that math. Okay, it may go back to radians then, I don't really know, I don't pay much attention. I mean, I just change it and check on it. All right, so here I go. Here's the inverse sine, it's right above the function, all right? So I'm gonna press second and sine, okay? And then I'm gonna go 200 divided by 400. 30 degrees. Now, we knew that, didn't we? We knew that, because 200 over 400 is 1/2. The sine of 30, who's opposite the 30 in the right triangle? 1, and what's the hypotenuse? 2. Who's opposite the 60? The square root of 3. See what I'm saying? All right, here we go. Last one. Example 9. Okay, so example 9 is like a skateboard ramp. Okay, so I'm gonna draw my skateboard ramp. All right, and here's what it says. It doesn't say anything, just gives you a picture, so I'll tell you. My skateboard ramp is 4 feet tall. My skateboard ramp is 4 feet tall. Does everybody know where the 4 goes? Where?
Right side.
Right side. Okay? The angle of elevation of my skateboard ramp is 18.4 degrees. The angle of elevation of my skateboard ramp is 18.4 degrees. So you got that one over here. You agree? How long is my skateboard ramp? Put the X where it goes. How long is my skateboard ramp? All right, tell me where the X goes, guys.
The top?
No,
That's how long it is.
that's right, y'all, listen to me. Y'all, this is, if you're riding on this, did you need a ramp?
No.
People, this is not how long the skateboard ramp is. The skateboard ramp goes from here to here. Will this side be longer than this side?
Yes.
Yes. This side, if you say it's only this long, you're gonna have a wreck. Cause it's gonna stop before it gets to the ground. Okay? So when I ask how long the skateboard ramp is, I want to know this side right here. That's how long the ramp is, all right? Now, let me ask you a question. What if I said, pretend like this is the sun right here, okay? And this is you right here. And the sun makes a shadow that is 5 feet long. The sun makes a shadow of you that is 5 feet long. Is that the X?
No.
No. People's shadows are not in the air.
They're flat.
That's right, they're on the ground. If you see a shadow in the air, that's not a shadow. You might wanna run, okay? So be careful about that kind of stuff, all right? So we're gonna label the sides, always with respect to the angle that you know, okay? Could I find this angle right here?
Yeah.
People, these two are complementary. You go 90 minus this and you got it, okay? So, with respect to this angle, what's this side called? What's this side called? What function deals with opposite and hypotenuse?
Cosine.
Sine. Oh heck. So that's my sine. So the sine of 18.4 is equal to opposite over hypotenuse. All right, so we're solving for x. Can you solve for a variable when it's in the denominator of a fraction?
No.
No, you cannot. I was so disappointed yesterday. Not one of my kids knew that. Not one of them. Okay? So you can never, ever, ever solve for a variable when it's in the denominator of a fraction. So you have to get it out of the denominator, and then you can solve for it. Okay? So what do I do? How do I get it out?
Multiply by 4.
Yeah. Multiply by what?
Oh, wait, X, yeah.
Yeah, multiply by x. I will finish this problem without you. Okay, so I'm gonna multiply. What you do to one side, you do to the other. What happens to these x's over here?
Cancel out.
And you're left with 4 is equal to x times the sine of 18.4. I'm solving for x, people. Tell me what to do. Divide by sine. Now, normally right here, I'd say x is equal to, and I'd write my answer. But I'm gonna rewrite it because I wanna show you something. All right, x is equal to 4 over the sine of 18.4. Okay, I want you to look at my beginning problem up here, and I want you to look with what I ended up with. What happened? That's exactly right. You see what happened? This guy went here, this guy goes here. Now it's gonna happen every single time because what are you doing? You're multiplying by this guy to get him out, and then you're dividing by this guy so you can solve for this one. All right, so every time it's gonna be this, so you're just gonna take your little calculator. You're going to say 4 divided by the sine of 18.4. And my answer is 12.67 feet. Is that a reasonable answer?
Yes.
If I had gotten 3 feet, would that have been a reasonable answer?
No.
No, certainly not reasonable. All right, anybody got a question? Okay, so these are the problems that I want you to work on. Remember what I told you. You use one of the books, okay? If you want to snap a picture, that's fine. If you want to take the book to your desk, if you're a book person, that's perfectly fine too, okay? But you make sure you put it up. I'm not putting it up, all right? I want it on notebook paper. It has to be in pencil. You need to show your work if necessary. Y'all, there will be some that you won't have to show your work, but if you had to find the side of the triangle using the Pythagorean theorem, I just want to see a little bit of work, okay? You can either box your answers in. I would suggest you box your answer in because you're gonna have a lot of answers. Sometimes they'll say, find all 6 true functions for this triangle. So just box it in, okay? If you're obsessed and you have to highlight it, the only color highlighter that you can use to highlight is yellow. I can't see through the blue and I can't see through the green, okay? I can, but I have to work really hard to do it, and I don't want to. Do not use a pink highlighter, please, because that's what I grade in, and that messes me up. So you're gonna do 2 through 16 the even, 20 through 26 the even, 57 through 62, all of them. These are word problems. You're gonna draw the picture and show me your work. It's really only 18 problems, so be careful, do them well. They're worth a few points, okay? All right. Everybody okay? And I'm gonna pass out your worksheets. And, oh, do I need to turn that back off? No?
That's it.
Remember that, it is Friday, so you should have joined Remind, okay? I hope that if I text you on Remind, that you're there, and that you do have a Teams assignment. Make sure that you understand the purpose of the Teams assignment. It is the only one that says for all students, all right?
I looked at it and one of the things was like, why are you doing this? Like,
Yeah.
Doing